We're going on now to topic 3.3, and this deals with solving word problems. Now, for many of these word problems that we're going to be doing, the concept behind it is that you're going to set up one equation in two variables, another equation in two variables, and you're hoping that the x and the y are the same, so you're looking for that point of intersection. So we're going to use those techniques that we showed in previous lessons, 3.1 and 3.2. Mostly the ones in 3.2, where we use either substitution or elimination. To give you some background of this section, here are some of the key words: distance, rate, time, that are put together in what we call the distance formula. Distance equals rate times time. And when we need those, we'll elaborate on that a little more. Then we're also going to have interest problems, where we have interest, principal, and rate. And that formula is interest equals principal times rate times time. So some of the words we'll be using as we go through the problems. Now, when we do problem solving, the key is, well, read the problem carefully. Often reading it once doesn't do it. You may have to read it more than once. Try to understand what they're saying there. And then convert the English into algebra. And that would give you your equations, solve the equations, and then check to see, does your answer make sense? So I'm going to shorten these instead of writing them out completely. They are in your little booklets. The sum of two numbers is 90. And here, being able to use two variables is actually helpful. So, two numbers, one number will be x, the other number is y, and the sum of these two numbers is 90. So that's pretty straightforward. Now, then they're saying the first number, which is x, is, and the word is translates to equals, 2/3 of the second number, which we said was y. So there are our two equations. We're looking to see where they intersect. And you might say, well, what technique would I use here to solve this? Think about it for a moment. Substitution, yes. Because you can put this value of x in terms of y into the first equation. So the first equation now becomes 2/3 y plus y equals 90. And then going back to chapter 1, where we had fractions in an equation, how do we get rid of our fractions? Well, we multiply everything by the least common denominator, which in this case is 3. So we'll multiply this by 3, this by 3, this by 3. Here the 3's cancel out, and we get 2y plus 3y equals 270. Add these together, we get 5y equals 270. Divide both sides by 5, and we get y equals 54. And if y equals 54, we put that into our first equation. We just now subtract 54 from both sides, and we get x equals 36. And if we add these two numbers together, that's our answer. So the ordered pair then is going to be 36, 54. Those are our numbers. So once again, read the question carefully and translate it into your set of equations. Solve it by either substitution or elimination, and then check your results. Number 4, again, read the problem to develop equations. Two angles are supplementary. Well, you might recall that supplementary angles are angles whose sum equals 180. So that's called a straight angle. If they're supplementary, the sum of supplementary angles, 180. So one angle will be x, the other angle will be y, and they're going to equal 180. So there's your first equation. One angle is 15 degrees less than twice the other angle. So one angle, x, is just translates into an equal sign, less than twice the other angle. Well, we're saying this is the other angle, so it's going to be twice that, less 15. So there are your two equations. Again, the angles are supplementary. That gives you your first equation. Then the other one angle is 15 degrees less than twice the other. So we didn't do a lot of practice in putting English into algebra, but you'll be picking up on it as we go along. And once again, you're asked, what method would you use here? Again, substitution. So you have this value of x in terms of y that you'll put here. So let's do this one. So this is going to be 2y minus 15 plus y, that's the other y, equals 180. Group like terms, 3y. We're going to transpose this to the other side. When we do so, it becomes a positive 15, and that becomes 195. We divide that by 3, and we get y equals 65. Well, if y is 65, we're going to just subtract 65 from both sides, and we get then that x equals 115. And remember, these are degrees. I wouldn't take off on a test if you forgot the degrees, but probably in math lab they'll give you a little box where you put this in and then the degree sign is there already. Once again, if you need to review this, just back up the tape and watch it again. So again, this would be our ordered pair where these two lines intersect. I've shortened this question a little bit to just put in the pertinent details. Here, there was a church that was offering a supper, a dinner, and the adult tickets were $6. Children's tickets were $4.50. They had 325 dinners served, and the total income, the total amount collected was $1,672.50. So that's the basic information. And I'd like you to read it over, think about it, and see if you could come up with the equations. Again, we're looking for two equations that will intersect at some point where it will tell us what our variables are. And basically what we have here is adults. Let A equal the number of adults dinners served plus C, the number of child dinners served. And we know that total amount was 325. And think about that for a moment. We don't know how many adult dinners there were. We don't know how many children dinners there were. But the total number was 325. Now we do know that the adult dinners cost $6. That would be $6 the number of adult dinners. $4.50 the number of children's dinners times $4.50, and that will give us our total amount, which is this, $1,672.50. And what you're looking for here is understanding what's going on and where these equations come from. Again, we had this many dinners served. This is the number of adults. This is the number of children. Now, each adult paid $6. Each child, probably the parents, paid $4.50. And that equals this amount of income. That was the amount collected. So there are your equations. Now, going back to chapter 1, we said that whenever there's decimal places, a good technique is to remove the decimals by multiplying each term by the greatest common denominator, which happens to be 100 here, 2 decimal places. So you're going to multiply this by 100, multiply this by 100. Just by moving the decimal place over 2 places, you get rid of all your decimals. Now you don't have to worry about decimals anymore. Now, when you get big numbers like this, you might wonder, well, how in the world will I solve this? Well, notice here we have an A and we have a C. So we can solve for the letter A. And that simply becomes A equals, we're going to transpose the C to the other side. and it becomes 325 minus C. So we now have an A that's in terms of C. So we go to our second equation, and where there's an A, we put in our C. And it will look like this. 600 times, let's put a 3 there, 325 minus C. And then now the A is gone, plus 450C equals now, I'm not going to solve this all the way. We did some of these before. But when you do finish it all up, we get that the C's come out to be, I've worked this out before, 185, and the A's come out to be 140. And these together make that. And this is the point on a graph where these two lines will intersect. The first equation, the second equation. Now again, there's lots of algebra here, lots of arithmetic, but use your calculator and work it through and you should get a good result. Okay, example 6 is a perimeter problem. And whenever we read that it's a perimeter problem, we should write the perimeter formula. That perimeter equals 2 lengths plus 2 widths. I would also make a figure of a rectangle in which I'm going to apply my information. Now we know the perimeter has a width and it has a length. Now as we read the problem, it says the total perimeter is 428 feet. Let me check that. Meters. All right, so it's in meters. It also says that the length of the rectangle is 4 more than twice the width. That's what they give in the problem. So I've put that. Here's the width. We don't know the width. We don't know the length, but we know the length is 4 more than twice the width. So what is our equation? Well, the first equation is going to be that this perimeter is 2 lengths plus 2 widths. That's our first equation. Now our second equation is that we know the length is equal to 2w plus 4. So based on reading the problem, and I didn't write it all out, it's in your booklet, we know this is the perimeter and it's 2 lengths plus 2 widths. That's our first equation. And then they tell us that the length is 4 more than twice the width. And that's how we write that. So now we want to see where is a point of intersection. And the answer is we can use substitution here. So let's do that. 428 equals 2. And now our L is, put it in parentheses, 2w plus 4, and then our other 2w. So now we're faced with, well, what do we do? Well, we got to get rid of our parentheses. I'll work on this one a little bit with you. 4w plus 8 plus 2w. And then always good to check. Check your work. Had a little cough there. And now we're going to collect like terms. That's our next move, and now we're going to transpose the 8. That becomes then 420 equals 6w. So w equals 70. So if our width is 70, what's our length going to be? Well, it was twice the w. So that's 140, 144. And if you put 144 here and 70 here, add it all up, you get 428. So this is the point where those lines would intersect with these two equations, systems of equations in two variables. For number 7, we have a company that produces candles in two sizes, 16 ounce and 24 ounce. And we're going to call the 16 ounce the X and the 24 ounce the Y. And altogether, this company sold 84 candles and made $959.90. They want to know how many of each kind did they sell. And I don't know if you realize it, but this is very much like an earlier problem we did with the children and adults dinners. In fact, that's the recipe we're going to follow. So we're going to say the X candles plus the Y candles added up to 82 candles. And that the X candles are 995 times the number of X candles that were sold plus 1295 of the 24 ounce candles, which we're calling Y, and the total income was $959.90. Again, it has decimals, so I strongly advise that you remove the decimals. Remember, you have to do it for each term. That gets rid of the decimals. You're probably going to use substitution. And that would give you an equation now with just one variable. So where you have the X, you're going to put in your value for X in terms of Y. So it'll be 995 times 82 minus Y equals, oh, no, not equals yet, plus 1295Y equals 95990. Again, it's a little laborious. You're going to have to use your calculator to do the multiplication, not here so much, but this one. Group like terms, transpose, and when you do, you find that x, because I've worked this out already, is 34, and y is going to equal 48. Now, if you don't get the answers, by the way, this is your algebra technique, your computation technique. The key thing that we're working on here is putting from words into equations and then solving, using your skill of solving equations to figure out that point of intersection. Now, if you need help, remember, there's help at the tutors, the Learning Center, here in Math Zone, and these are the answers. Remember, the answers are in the back of the section. All right, number 8 is a typical, what we call a mixture. A mixture problem. And you're mixing things that have different values. So here we have dried apricots that are $12.25 a pound, dried apples that are $7.50 a pound, and you want to mix them together to end up with a mixture that sells for $9.40 a pound. And you want to make 40 pounds of it all together. So how many pounds of apricots, how many pounds of apples to get this mixture? And we're going to use system of equations to set this up. Now let's call, since they're both A, let's call the apricots X and the apples Y. So our first piece of information, and this is going to be true for many of our mixture problems, is that X plus Y will be 40. That is, this stands for a number of pounds of apricots, and this stands for a number of pounds of apples. Altogether, it's going to be 40 pounds. Now, what do the apricots cost? Well, 12.25x. That will be the cost of the apricots plus 750 of y, the number of pounds of apples, and you want it to sell for $9.40. And how many pounds? You want 40 pounds. So there are your two equations. And I know initially when you start to read these, they're difficult, but they're going to follow a pattern, and that's what you're going to try to pick up on. What is the pattern? So again, you read the problems carefully, and I didn't write it all out, but I picked out the pertinent information. Apricots, this. Apples, this. Total number of pounds, this. Apricots plus apples equals 40. Cost of apricots, cost of apples, total cost of your 40 pounds. So once again, how do you solve it? Well, get rid of the decimals. And then you're going to use substitution. And remember, the y are the apples. You put it into your other equation, grind it out, and interestingly, for x is going to be 16, and for y, it's going to be 24. And of course, these are pounds. If I were to solve every problem, it would make the tape very long. Again, our interest here is to have you be able to convert from English into algebra.